Today we are going to discuss primal dual relationship in linear programming and shadow price concept. The primal problem. Here we are taking the production problem. That is product mix problem. Given here just to save the space. But I am discussing what is the production problem. Suppose the production centers, the machine centers consist of three centers X, Y, and Z. It may be, say, grinding, polishing, finishing. After passing through these three centers, the finished product will be produced. The manufacturer is producing three products. Say the name is A, B, and C. For producing the A product, the machine center X require 10 hours. That is, say grinding department needs 10 hours. Y centers, say polishing center, needs 7 hours. And the finishing centers, Z, needs 2 hours. And after passing these three centers, 1 unit finished product of A will be produced. If you sell that product in the market, the profit per unit is 12. Similarly, for product P, center X requires 2 hours, center Y requires 3 hours, and Z center finishing centers require 4 hours. And after passing the centers, product B will be produced 1 unit. And if it is sold in the market, say the profit per unit is rupees 3. For C, the product passes through grinding section through X is 1 hour, and machine centers Y, that is polishing centers 2 hours, and finishing centers 1 hour, and finally the product C will be produced. And if it is sold in the market, the profit will be rupees 1 per unit. The resources are limited. Say the total resources of X center is 100 hours. You cannot run that center, that is grinding machines, more than 100 hours for a specific period. This period may be 1 week, 1 month, even 1 day also, for a specific period. For polishing centers, the limited hours available is 77 hours. And for finishing centers, the limited hours, you cannot use or run that center more than 80 hours. Then you have to find out the best production mix. That means how much or how many units of product A, B, and C you will produce, so that the production is possible within that limited hours available for the machine centers, and at the same time, as this is a case of profit, the profit will be maximized. This is the primal problem. Suppose we are assuming we are producing product A x1 units, B x2 units, and C x3 units. We have to determine the value of x1, x2, x3. First stage, we have to formulate the problem in quantity terms. Now first, for constraint of grinding machines or grinding centers X, the total hours required will be 10x1, as for 1 unit of production of A requires 10 hours, x1 units needs 10x plus 2x2 plus 1 into x3. This is the total hours required for producing x1, x2, and x3 units. Must be less than equal to 100 hours. That's why this constraint is written for grinding section, or you can say center X. 10x1, 10 into x1 plus 2x2, same our machines, plus 1 into x3 less than is equal to 100. Similarly, for polishing center, 7x1 per unit production needs 7 hours, x1 units needs 7 into x1 plus 3 into x2 plus 2 into x3 less than is equal to 77 hours. This is your second constraint. And the third constraint, 2x1 plus 4x2 plus 1 into x3 less than equal to 80 hours. x1, x2 and x3 is the production unit. It cannot be negative. That's why mathematically x1 greater than is equal to 0, x2 greater than is equal to, and x3 greater than is equal to 0. This is called non-negativity constraints. So all these are the constraints. Now objective function. How we determine the objective function? This is a maximization problem as we are considering profit per unit. If we are considering cost per unit, then what will be the problem? Always we will try to minimize the cost. When we consider cost, then it will be a minimization problem, cost minimization problem. But in this case, it is a maximization problem. Per unit of product A will give rupees 12 profit per unit. As we are assuming x1 units of production, that's why 12 into x1 is the profit for product A. Plus 3 into x2 is the profit for product B, and 1 into x3 is the profit for products. This is the total profit, and we have to maximize it. Then what is the linear programming formulation, which is called the primal problem? Maximize z is equal to 12x1 plus 3x2 plus 1x3 subject to all these constraints. Now, for each primal problem, there is also a dual problem. What do you mean by dual problem? Actually, primal problem from the side of the manufacturer, but dual problem, same problem, if we consider the problem from the side of the investor. Suppose for the same problem, one investor is coming, he is interested to purchase all the resources, that is interested to invest for the project, and for that purpose the investor offering rupees W1 per hour of the resources X, that is grinding machines, and rupees W2 per hour for polishing resources, say Y, and rupees W3 per hour for finishing centers, that is Z in this case. Then what will be the situation? The total investment from the side of the investor will be 100 into W1, because W1 is the cost per unit of the resources X. Total resources 100, that is W1 into 100. This is plus 77 into W2 for these resources, finishing department, polishing department, plus 80 into W3 for the finishing department. That is, investor will try to minimize this total investment cost, subject to the manufacturer will have no objection to sell the resources if he gets per unit of production A at least rupees 12. How much the manufacturer will get for these resources? Instead of a product needs 10 hours per hour, manufacturer will get W1 rupees, that means 10 into W1 plus, I am considering for this product, 7 into W2. For these resources, the manufacturer will get this much amount, and for these resources, the manufacturer will get 2 into W3. If the total of this, whatever the amount the manufacturer will get by selling the resources, is greater than or equal to 12, that is at least rupees 12, the profit per unit, then manufacturer will not mind to sell the resources. Similarly, for product B, we can write 2 into W1 for the resources X plus 3 into W2 plus 4 into W3 to that is equal to 3, because 3 is the profit per unit for this product. And for product C, W1, the cost is W1 per unit. This will be given by the investor to the manufacturer. For 1 hour, he will get 1 into W1 plus 2 into W2 plus 1 into W3, that is equal to 3A. W1, W2, W3 is the price which are offering. It cannot be negative. That's why W1 greater than W2, W1 greater than 0, W2 greater than equal to 0, and also this greater than equal to 0. This is the dual problem. There is a mathematically relationship also between primal and dual that I will discuss later on. And from this, after solving, we can see whatever the result for primal, that is the maximum value for the primal problem is same as the minimum value of dual. That I will show you later on. And from this, we will get the concept of shadow price. That will also be discussed. Thank you. Continuation from the previous page. In my previous page, we have formulated the primal and dual linear programming problem. Now we are going to solve it. First, convert all the inequalities to equalities by inserting slack variables, say x4, x5 and x6, and accordingly revise the objective function also. If we insert the slack variables, the constraint will be like this. Now first I am showing the constraint. One will be written as 10x1 to x2 plus 1 into x3, the slack variable plus x4 is equal to 100. To complete the matrix form, I have also shown here 0 into x5 plus 0 into x6. Similarly, after converting the equation 2, after inserting the slack variable x5, the equation will be 7x1 3x2 plus 2x3 plus x5 is equal to 77. And third equation will be written in this form. Here all slack variables are greater than or equal to 0, and I have already mentioned x1 and x2, x3, the decision variables also greater than or equal to 0. The objective function will be like this, because the slack variables has no contribution to the objective function. Slack means the unutilized resources. For fast resources, in this case it is grinding machines like that, the excess hours is x4, which is not being utilized. If the total utilized, say the hours is 70 hours, then x4 will be 30 hours to make it easy. So this is unutilized resources, and for that reason, to the objective function, the coefficient added to this slack variables is 0. Similarly, for x5 and x6, the coefficient is written as 0, as x5 and x6 are also slack variables which has no contribution to the objective function. It will not maximize or it will not give any contribution to the objective function. And that's why the revised objective function after incorporating the slack variables will be like this. Now we are just showing this objective function and constant in the matrix form, because we will solve this linear programming problem by simplex method, that is nothing but the application of matrix. If we write in the matrix form, then you see this is the row 12, 3, 1, 0, 0, 0, and this is the column. And if you multiply it, then it comes to this. That means maximize, if you write in the matrix form, this is nothing but maximize z is equal to cx. C is the this matrix and x is the this matrix, column matrix, where x greater than is equal to 0. If we write the constraints in the form of matrix, then it will be like this: 10, 7, 2, first column, 2, 3, 4, 1, 2, 1, and 1, 0, 0, 0, 1, 0, 0, 0, 1. For that reason, to complete the matrix, we have inserted 0 into x5, 0 into x5, x6 like that, and is equal to 100, 77, and 80. This is another matrix. And if we write in the full form, and we can write subject to, this is A matrix, this is X matrix, this is C. That means subject to AX is equal to B and X greater than is equal to C. That means in the matrix form, the linear programming problem is maximize Z is equal to Cs, subject to Ax is equal to B, and X greater than is equal to 0. This is the standard form of the maximization problem. And it is minimization problem, then it would be written in different way that I will discuss in my separate video. Okay. Now, if we transfer this matrix to the simplex table, then the first simplex table will be like this. This is nothing, this C matrix. C 12, 3, 1, 0, 0, 0. It is written the top of the simplex table. Now x1, x2, x3, x4, x5, x6 is written here, and this matrix, that means A, is written 10, 7, 2, 2, 3, 4, 1, 2, 1, like this. And CV means the coefficient of the basic variables. These are the basic variables. Actually, in this case, the basic matrix will be taken this 1, 0, 0, 0, 1, 0, 0, 0, 1. And if you solve it, then the solution will be x4 is equal to 100, x5 is equal to 77, and x6 is equal to 80. How it has come, if you want to see, then I can show you here the rough work. Because actually in this problem, you see there are 3 equations but 6 variables. We can't solve this equation in unique way. We can solve in unique way maximum 3 variables, 3 equations. That's why we have to put 0 for other variables. For convenience, actually we used to take the basic variables as x4, x5, x6, and rest variables are put as 0. That means we assume x1 is equal to 0, x2 is equal to 0, and x3 is equal to 0 in the first case, and the basic variable and the basic matrix is 1 0 0 0 1 0 0 0 1, and this x4 x5 and x6, and if you solve it, is equal to 100 77 and 80. And if you solve it, will be very easy to solve it. Row into column, that means x4 is equal to 100, x5 row into column, x5 is equal to 77, and x6 is equal to 80. That is actually written here. The solution of the basic variables x4 is equal to 100, x5 77, x is equal to 80. And this is the coefficient of the basic variables. And if you put the solution in the objective function, and you can see the value of z will be 0. Value of 0 will be 0. Why value of z will be 0? Because x1 is equal to 0, x2 is equal to 0, and x3 is equal to 0, and x4 is equal to 100 into 0 to 0, 77 into 0, 0. That means all this will be 0. That's why the first stage, the first after first table 1, simplex table 1, the objective function will be 0. x4 is equal to 100, that I have shown you why it has 100, but still it will not contribute to the objective function as coefficient is 0. Now we have to move forward for the best solution so that the objective function will be increased. Step by step we will increase and we will solve by simplex table. For this reason, for that we have to do simplex iteration. I am not going to show the detailed process for solving the simplex problem, because our main purpose is to show that how you will get the solution of dual from the primal itself, and also to get the concept of shadow price. That's why I am assuming that the students are aware to solve the simplex iterations, and by that this is the final simplex table for this problem. This is the, you can try yourself, this is the final simplex table. Actually this is the solution. In this box you will get the solution of the problem. In this case the solution x4 is equal to 100, x5 is equal to 77, x7, x6 is equal to 80, which are not available in this column or box. That is equal to 0. It is understood all that variables are 0. That means in this case x1 is equal to 0, x2 is equal to 0, the x3 is equal to 0, as they are not counts under the basic variables. But in the final table, the solution x1 value is 73 by 8, x2 variable 35 by 8, and x6 is equal to this. And all these are the index of value. As all the index of values are greater than or equal to 0, that's why optimum has been reached. And these are the solutions. Then what will be the maximum value for this problem as per linear programming problem? The objective function is 12x1 plus 3x2 plus 1 into x3, and rest is 0 into x4, 0 into x5, like that. So putting the coefficient of the variables or solution, that is 12 into x1, and putting the value is 73 by 8, the value of x1, plus 3 into the value of this 35 by 8, plus 1 into x3 is not available here in the basic column. That's why the value of x3 is equal to 0. It is understood. x4 is also not available. That's why the value of it is 0. And x5 is also not available in this column, 0. But x6 is 177 by 4. That's why it is written here, but the coefficient is 0. If we simplify, then you will get the value is 981 by 8, and this is the maximum value as per linear programming problem. Now, in my next page, I will show you that the solution of the dual problem, which we have already formed in my previous slide, is available in the final table of the simplex. How? If the primal problem is in the standard form, in this case this is the standard form. Standard form means ax is equal to ax less than is equal to 0, ax less than is equal to 0, and maximize z is equal to cx. Z is equal, this is the standard form of the linear programming problem. In that case, the solution of the dual problem will be available in the final simplex table. Where it will be available and how? The value of the slack variables will represent the solution of the dual variables. That means in this case, which are the slack variables? This is the slack variables. Which are the index of values? This is the index of value, this and this. And your dual variable we have discussed in that problem was W1, W2 and W3. Then what will be the value of W1 variable? It will be corresponding to the index of value of this slack variable x4. That means the solution of the dual problem, the variable W1 will be 15 by 16 and W2 will be, this is the second one, 3 by 8, and W3 will be, as the slack variable x6 is the W3 is corresponding to 0, that's why it will be 0. This will be the solution. This will be the solution for the dual variables. How we will believe that this is so, that I am going to discuss in my next slide. Thank you. That is my next slide. What I will do, I will first show you these results are correct solution for this dual problem that I will show. That means the minimum value of the objective function will be 981 by 8. And after that, how you will use this concept for determining the shadow price and what is the concept of shadow price, that I will discuss in my next slide. Thank you. In my previous slide, I have already discussed how you will get the solution of the dual problem from the primal problem of the linear programming itself. You will get the solution from the final simplex table. The result of the dual variables will be available from the final simplex table corresponding to the index row value of the slack variables. In this problem, the slack variables are x4, x5 and x6. That's why for the dual problem, the solution, which I have already mentioned at the time of formulation, the dual variables are W1, W2, W3. Then the value of W1 will be corresponding to the slack variable x4 of the index row value, that is 15 by 16. That's why I have already written W1 is equal to 15 by 16. and the value of the second dual variable, that is W2, will be corresponding to slack variable x5, that is 3 by 8 from the index row, and the value of the third dual variable, that is W3, will be available from the corresponding slack variable value of the index row, which is 0 in this case. That is W1 is equal to 15 by 16, W2 is equal to 3 by 8, and W3 is equal to 0. I had already shown at the time of formulation the objective function of the dual problem is minimize z dash is equal to 100 into W1 plus 77 W2 plus 80 W3. Now we put the value of W1, W2, W3 to the objective function and check whether the result comes is same, which is the maximum value of the primal problem. That's why we are going to put the value of dual variables in the objective function, that is z dash 100 into W1 is 15 by 16 plus 77 is 3 by 8 plus 80 into 0 is W3 is 0. If you simplify it, then you will get the value will come 981 divided by 8, which is same as the maximum objective function value of the primal problem. Then what is the conclusion? That is, you need not to solve the dual problem separately. The solution is available itself in the primal solution. If you solve the dual problem, then you will get the solution of the primal, and if you solve the primal problem, then you will get the solution of the dual. That we have already checked also. And this is the process by which you can get the result of dual variables and the objective function for dual problem. Now, the last part, the shadow price concept. What do you mean by shadow price? You see, this is the objective function for the dual. 100 is the resources available in the manufacturing problem, 100 hours for grinding, and W1 is the price per hour which is offered by the investor, and 77 is the constraint or available hours for grinding section or grinding machines, and the investor offered the price for these resources per hour W2, and 80 is the finishing department available capacity or hours, and the investor is offering W3 rupees per hour. Now if we put the value of dual variables, that is W1, W2, W3, it will be written in this form. Now see one thing, what will happen if the constraint, that is the limited resources in this problem, the 100 hours for grinding, is increased by 1 hour, that is in place of 100 it is 101, then what will be the effect on the objective function? The objective value will be increased by 15 by 16, because in place of 100 you will write 101, because 1 hour resources is increasing, and you will get the maximum value extra 15 by 16. This is the worth of the limited resources for grinding machine. Whatever the first is grinding, polishing and finishing. This is the grinding, and the manufacturer is ready for pay 1 extra hour of the resources for grinding or first resources by 15 by 16 rupees, as the profit will be increased by 15 by 16. That's why this is called the shadow price. It is not written anywhere. This has become comes out from solving the problem, and you can say it is the imputed price. For the second resources, 77 hours, that is polishing, I think. You check 77 hours. If 1 hour is increased for anyone's supply, then manufacturer is ready to pay rupees 3 by 8 units per hour, because if in place of 77, if it is 78, the objective function value will be increased by 3 by 8. And this is the work of the second resources, or grinding, I think, in this case. And this is called the shadow price for second resources. And for third resources, it has no value, because the value of W3 is 0. If the constraint 80 hours, that is finishing department, if you increase 90, 100 hours in it, the objective function value will not increase. That means the manufacturer will not pay, will not be ready to pay any amount for supplying, extra supplying of the resources 3. That is, in this case, finishing department hours. And this is the concept of shadow price, which comes out only after solving the problem by dual concept. Thank you.